Hey everybody, so in this video we're going to be solving this ODE using the method of undetermined coefficients. So uh, the general solution is we have, the solution would be split in two parts. We have the y sub p and y sub c. The y sub c is when you treat it as a homogeneous differential equation, so you just set the right side equal to 0 and solve for your linearly independent solutions. Then we move on to the y sub p, and I'll show you how we solve for that. So to begin with, we want to find the y sub c and set it equal to 0. So basically treat it as a homogeneous differential equation. Oops. So we have y double prime minus 3y prime plus 2y equals 0. So we can go ahead and write since we know we have right here, we have constant coefficients. So constant coefficient here, constant coefficient. So we can just go ahead and write the auxiliary equation, and that would be m squared minus 3m plus 2 equals 0. Okay, and then find your solutions, and then that would be, just simplify this even more, factor it. So then you would get m minus 2, and then m minus 1 equals 0. So we know our m's are equal to 2 and 1. Okay, so since it's second order, you know that your differential equation needs to have two linearly independent solutions. So we go ahead and then write our y sub c being equal to c1 times e to the 2x plus c2 times e to the x. Okay, that's our y sub c, but we're not done yet. Now we have to find the y sub c. Okay, so we look on the right-hand side, and then we see the function, not worrying about the coefficient, okay? So our function is x squared. All right, so we can go ahead and write that here. So we have x squared. What we're going to do is keep taking derivatives and not worrying about the coefficients until we reach 1. So take the derivative, you get 2x, but we said we're not going to worry about the coefficient, so we just get x and then 1. And then we stop right here. So now we have a set of functions, and that is x squared comma x comma 1. Okay, so then our y sub p, okay, so our y sub p would then be equal to a undetermined coefficient in front of each of these three elements in our set. Okay, so we get ax squared plus bx plus c. And we're just going to take two derivatives, okay, and then we're going to plug these into our initial differential equation, and then solve for a, b, and c. So y prime, okay, so y prime would then be equal to 2ax plus b, and the derivative of constant is 0. Okay, and then for y double prime, we get 2a, and the derivative of b is just 0. So now we're going to plug these in, as I said, here into our initial differential equation, and that would be 2a plus negative 3 times yp prime. So that's with a negative 6ax minus 3b plus 2 times y sub p, so that's 2ax squared plus 2bx plus 2c. And that is equal to the right-hand side, which is 4x. Oops, running out of space. So that is equal to 4x squared, the right-hand side. So we're just gonna group these. Okay, so the x squareds, the x squared, I'm gonna group them together, factor them. So then we only have a 2a plus anything that has an x with it. That would be minus 6a plus 2b. Okay, and anything that doesn't have an x or x squared, just a number with a letter. So that would be, you can think of it as like a 1 in front of it. 2a minus 3b, and then plus 2c. okay, equals to our 4x squared. So now what we're going to do is set each of these equal to their corresponding, so like if you have an x squared here and a 2a in front of it, you're going to set it equal to the 4, and then what's in front of it is x squared. So you have x squared 2a equals to 4x squared. Okay, so the x squareds and the x squareds cancel, and you're left with 2a equals 4, so a is equal to 2. And then you do the same. So is there anything that has an x in front of something on the right hand side here? And the answer is no. So you just set it equal to 0. So negative 6a plus 2b equals 0. And we know a is equal to 2, so that's negative 12 plus 2b equals 6. So b equals 0, so b is equal to 6. All right. And then finally for c, so same thing, we don't have, we just set that equal to 0, and then you write it right here. So then you have 2a minus 3b plus 2c equals 0. And we know a is equal to 2 and b is equal to 6, so that's 4 minus 18 plus 2c equals 0. So 4 minus 18, negative 14, move it to the other side, divide by 2, you get c is equal to 7. Alright, so I need to go ahead and make some room. Okay, let me just, let me just erase and make a little space. So just erase all this. This is not going to work well. Let me see. Just going to make some space. Alright, so finally what we have, I'll write in a different color. So then our final solution would be a combination of the y sub p and the y sub c. And our y sub c would be, so let's first write the y sub p. The y sub p would be ax squared plus bx plus c. And we know a is equal to 2, so that's 2x squared plus 6x, and then c is 7 plus 7. That's our y sub p. And then plus our y sub c would be just that right there, and that is c1 e to the 2x plus c2 e to the x. Oops. And that would be it.